Hello, everybody, and welcome to the European Marine Board's third Thursday Science webinar series. I'm Sheila Heymans, your moderator for today, and I am really looking forward to this talk today by Roberto, who you can see on your screen already. Just some housekeeping rules. Please make sure that you have your name entered so that we know when we come to it who's asking the questions. Please use the Q&A, which you should see at the bottom of your screen, to ask those questions. And it'll also be helpful if you actually add in there where you're from, what country, which organization. Once Roberto has finished his talk, I will look through the questions and moderate the discussion. If you have any technical issues, please put it in the chat, and some of the Marine Board staff will help you. Be aware that this webinar is being recorded and it will be made available on our YouTube channel and on our website. So that's all of the important administrative bits. More importantly, though, today's talk is actually highlighting some of the work that is going into the new Future Science Brief on the deep sea research and management needs. That's you can see a picture of there. Which will be launched on the 11th of April, and you can register there at the link which you'll find on our website. The talk today will be given, as I said, by Roberto, and it's on the restoration of these deep sea habitats to rebuild European seas. Roberto is an ecologist and a professor of marine biology at the Polytechnic University of Marcia in Italy, and he is a member of the working group that has written this document, which will be launched. So without further ado, I'm going to stop sharing, and Roberto, it's over to you. You're muted. You're muted.
I'm muted. Thank you very much, Sheila, for the presentation, and thank you to all of you for the opportunity. Let me share immediately the screen so that we can share the presentation to all of us. And here we are. Hope you can see it.
Yep, and it's in full screen mode. Perfect.
Okay, so I'm very happy to be here to introduce you to a topic that was treated in the last European Marine Board document on the deep sea, which is dealing with the restoration, in particular the restoration of deep sea habitats, that is part of the Nature Restoration Law. As we know, is particularly within the Article 5, so could be a hot topic, but is still full of issues to be solved. So I'm happy to illustrate some of the problems and the needs that are regarding this topic. First of all, we know that we have documented that there is an increasing impact on the deep sea. I'm mentioning not just the chemical impacts, the climate change or whatever, but with respect to the restoration issues, we are dealing especially with the physical impacts and damage, which are linked to the offshore drilling, and particularly the sea cables and activities that are occupying the seafloor, creating a complex, intricate link. Just to make an example, in a very small Adriatic Sea within the Mediterranean basin, which is just the 15th of the Mediterranean basin, so what can be something like 0.1% of the oceans, we have 2,000 kilometers of sea lines related to the gas and extraction activity. So this is one of the problems we have: pipelines and connections, cables of various types, not to mention incoming and future problems related to deep sea mining and mineral extractions. All of this makes not just very crowded the deep sea, but increasingly threatened. And as we know, these are issues that sometimes are difficult to document, but are certainly able to create a physical damage. In addition to that, we have, besides the issue of the deep sea mining, which is quite largely discussed, dealing with the European Union and related also to another just produced report on renewable energies by the European Marine Board, we have a growing opportunity, which is related to the floating offshore wind farms, which are by definition floating, thus they are anchored on the seafloor at depths that are touching now 900 meters. This again could be an additional source of potential impacts on certain habitats if not adequately located, and if there are no previous interventions to identify the exact location of the anchoring. And then we have the problem of the sea lions and the connection with the continent. So we are facing a world in which we have evidence of beauty of the deep sea, which sometimes is also threatened by also the dumping or the large macro litter, the ghost fishing, the abandoned fishing nets and gears. And these are also problematic because, as you can see here, in some cases, we have also deep water corals, madreporians, and others growing on top of these surfaces. So we have from one side the impact on life, and from the other, and the physical damage, alteration of the seafloor, and from the other side also an opportunity for life to recruit on top of them. So in addition to that, we know that deepwater trawling and bottom contact fisheries are physically damaging the seafloor, and fishing activities are very, very intensive at between 300 and 600 meters, but can easily go down to 1,000 meters. Although, for instance, they are banned in the Mediterranean beneath 1,000 meter depth, but sometimes they are carried out also there. And you can see here that the fish biomass and the other biological resources are, interspersed with bottles and other sources of marine litter. All of these are able to create, this is another image from Sweden, another location that we are investigating within the frame of the project Redress, to census the physical damage of deep water habitats. They're creating, scars, they're creating, physical perturbations and altering the seafloor, removing the benthic organism, altering the characteristics of the deep water habitats. And this is something that is very, very intense, related also for the fisheries of deep sea shrimps. And there are several papers, including this one, published by the Catalan colleagues, Spanish colleagues on the Catalan margin. The yellow parts indicate the fishing activities that are surrounding the canyons and are particularly intense, so that a lot of sediments are physically disturbed by this activity. It is calculated that we have almost 5 million square kilometers, so something like equivalent to 1.3% of the global ocean, which is physically damaged every year by this kind of activities. This kind of activities, in addition, is able to create a chronic impact over the seafloor, and we demonstrated with the publication published on PNAS that the bottom trawling is also altering the food sources and food quantities, and have an impact also on the small size animals, not just the megafauna, but also on the meiofauna. In other words, trawling at 500 meter depth is equivalent to transform these deep sea habitats to those that we can see in terms of biomass and function at 2,000, 2,500 meter depth. So it is an evident depletion of life and functions. And we know that the problem, the seabed trawling has been treated by many times to protect deep sea biodiversity. And there are several regulating, proposals, including the one now restricting the fisheries below 600-meter depth. But despite this has been, discussed already 20 years ago, we still are lacking of a strict regulation for the physical impact of the water trawling. In addition to that, I just mentioned before the emerging problem of the polymetallic nodules and the evident physical impacts created by these kind of bulldozers, which are sucking and extracting the nodules from the seafloor, thus creating evident alteration, perturbation, and removal of some hard substrates, which are colonized by a series of animals in systems like the deep sea in general, and these systems in particular, which have a very slow resilience. These attempt of dredging and these scars created by attempts done more than 30 years ago are remaining the same after 30 years, showing no sign of recovery. And not just because of the lack of nodules, which are known to require thousands of years to be recreated, but also for the life which is colonizing the deep sea floor and the abyssal sea floor in this specific case. Given the huge extent of the Clarion-Clipperton zone, but also other manganese nodules and others areas showing concentration and opportunities for mineral extraction, this is going to be probably the largest intentional human impact on Earth since the existence of humanity, of course. We have this together with the acceleration of deepwater warming, together with the multiple impacts, which might, of course, also threaten or alter the resilience or the response of deep sea ecosystems. But just to make a case, in the Western Mediterranean, the deep water warming at 1.6 kilometers depth has been in the last 15 years twice as fast than in the previous 30 years. So the increase of temperatures on the deep sea, on deep water masses in the last 15 years has been equivalent to that was recorded in the previous 30 years. So this indicates a kind of acceleration of deep water warming together with many others. So now it is clear that to contrast climate change, to find solutions, many attempts have been done, including the potential use of deep sea ecosystems to mitigate the climate change. And so to suggest potential climate intervention, mitigating intervention or adaptations in some cases, but among those suggested so far several, including, growing of macroalgae then delivered on the seafloor, ocean thermal energy, increasing, liming, alkalinity addition, whatever. All of these solutions might have additional impacts on the deep sea floor and eventually can physically disturb or alter the sea floor. So we should also consider the potential threat due to the interventions that are positive for contrasting climate change, but potentially negative for the equilibria and even the survival of some deep sea ecosystems. So given that premises, we need to understand what is which are the solutions, which is the approach that we want to use for solving the problem. And we know that at the European level, we are developing a systems that is a kind of concentric cycles of actions, which include the contrast to the pollution, including, of course, marine litter and contrasting climate change. But of course, this is not sufficient if we do not protect habitats, and I would say if we do not protect deep sea habitats in this specific case, to stop biodiversity loss and habitat loss. But we do also have to make some attempts to do something for the habitats that have been already damaged, physically damaged, and on which we have a little hope of a natural resilience and recovery. So we need to restore and to do active restoration interventions on deep sea habitats as well. Of course, we have the alternative, which is included also in the natural restoration law, of a passive restoration. That is just that instead of protecting pristine areas as we do in marine protected areas, we protect areas that were previously rich in biodiversity and now have been degraded or destroyed by physical interventions or trawling. But it's possible that passive restoration interventions might require, depending case by case, of course, and habitat by habitat, but might require 100 years. Or in any case, think about, a deep water coral, bank or whatever, might require several decades. And we need to accelerate that for many reasons, including the fact that deep sea ecosystem restoration is one of the nature-based solutions to contrast the accumulation, of course, of carbon dioxide in the atmosphere. So one of the potential that we wanted to explore and on which the European Union is leading, actually, I could say, worldwide, is the attempt to restore deep sea habitats, convening efforts on several research groups, institutions, academia, and private companies within the frame of a project initially started in 2015, the Project Mercies, then had a follow-up in 2024 with the start of the Project Redress to attempt to specifically restore deep sea habitats, which is one of the most challenging issues, of course, because it is already known that it could be problematic to restore a seagrass or a mangrove forest, but it could be even more difficult to restore deep sea ecosystems. Of course, when we talk about deep sea ecosystems, we are talking about a multitude, a plethora of deep sea habitats for which we have no experience at all, because most of the experience accumulated so far is, for instance, on deep water corals. Yet, we have to demonstrate that we can do that, and we can be very successful to promote investments and also to develop a kind of opportunity for private companies to invest also on deep water ecosystem restoration. First of all, however, if we need to demonstrate the success, we need to define the success, which could be defined as an intervention that enables the recovery of the biodiversity and ecosystem functions. And the two have to go together, because if you do not recover biodiversity, but you just recover some ecosystem functions, you don't have a real restoration, but you have, other, recoveries, which are partial recoveries, but are not restoration stricto sensu. And you return to values that were not significantly different from those that were before the impact. To do that, we wanted to explore a number of deep sea habitats that are spanning from Iceland to Israel, covering either Atlantic areas and the Mediterranean Sea, along a number of systems, including the cold water coral of the Arkmount province in Ireland, the Lophilia pertusia colony damaged by longlining in Iceland, coral colonies in the North Sea, others, including soft sediment communities in Sweden, in the Mediterranean Sea, Madrepara reefs, and others. And for the first time, we also wanted to address the potential of recovery of coal seeps assemblages and habitats, which were not attempted before. But of course, if we work on the deep sea, the technological issues are possibly dominating the problem, because we need, of course, good methodologies, but also we need to do that, of course, we can't do it by diving if we don't have an ROV or other tools to work in the deep sea, to manipulate, to introduce, to recruit, and even to allow spatial upscaling, because of course we need to also to cover important dimensions. And the more we are able to use technological solutions, and the more we can expand the restoration effort, while at the same time decreasing the cost per hectare, the cost per unit restored, which is another essential problem. Because if you see this issue from the point of view of the investors in the restoration, either it is a mangrove or a deep water coral habitat, the banks or the investor will ask you, yes, I can do that, but what is the success probability or the risk of failure? And the second, they will ask you, what is the return of investment? So how long I need to wait before I get back in terms of tangible values eventually, but also intangible if you want. But when I get back a result of my investments. And in that perspective, so we start in a various way, because if you are willing to restore deep sea habitats, one practical, easy solution that was adopted in shallow water habitats, think about, seagrasses, has been take the seagrass sod from one side and transplant that in a place where the seagrass has disappeared or has been damaged. But in that case, you have the risk of losing an additional fraction of habitat, because you are partially damaging a healthy seagrass meadow to recreate or try to recreate another one. Is that sure that we can do that without causing a partial damage in the source area? So we are looking, and here we are, have some an examples of the system we are developing, and what we call the wedding cake here, this 3D reef that was designed especially for this project, and the arms that are posed on this deep recruitment system. So we want also to recruit a natural larvae and create juveniles and new recruiter to expand the effect of recruiting, instead of taking colonies and transplanting colonies from one place to another one. So this is potentially one of the key issues to increase the efficacy, but also the sustainability of the restoration interventions. Of course, this is an example of the activities we were recently carrying on in the deep sea canyon of the Mediterranean Sea in front of Naples, the Dorn Canyon facing the Stazione Zoologica Canton of Naples. And here you have also an idea of the dimension of the deployment of these that we call wedding cakes, multiple layers that are being used in various areas from Ireland to the Mediterranean Sea, from the Tyrrhenian Sea to the Southern Adriatic, also in the frame of the Life Dream project. And these, systems have a double advantage. From one side, they recruit new larvae. From the other side, they increase the surface using eco-compatible materials to recruit sessile organisms, which are exactly those we want to reintroduce. And then when these surfaces are covered and by corals or other deep sea organisms of interest, they can be transplanted in new areas by, in this way, expanding the recruitment also in areas that deserve this recruitment, and at the moment have no available surfaces, or not, there are no the conditions for their growth. And these are also attempts that are being done and have been done already in the Azores, for instance. Another opportunity is related to the removal of the marine litter, which is, as I showed before, contains several important and threatened species, including some 15 species which are listed in the IUCN list of endangered or threatened species, or look at these deepwater corals which are colonizing the rigs of offshore platforms. So instead of removing the litter, decommissioning the systems, losing also these beautiful life forms, why not taking them and explore the opportunity to use these organisms and the reef effect created by these structures to move these organisms in other areas to be recolonized. The problem is that deep sea restoration more problematic than the other marine systems. To do that, we compare the efficacy of deep sea restoration with other habitats, seagrasses, tropical coral reefs, and other. And so we collected a large number of studies down to 1,000-meter depth, and we then made a statistical comparison and a meta-analysis on that. And you can see here that on average, the success of marine ecosystem restoration spanning from seagrasses to salt marshes, coral reefs included, cold water coral included, is more than 60%. And the cold water coral restoration is right in the middle of this list. And in some cases, the restoration of deep sea ecosystem is close to 70%. Of course, we haven't a large number of cases, and so these numbers can change according to the future attempts and experiments. But this is a very good percentage because it is generally assumed in the restoration of seagrasses that the restoration is successful if after the transplant, 50% of the transplanted organisms are surviving. Then, of course, this is just a start for the future restoration. Another issue is, are there attempts at global scale? Yes, there are. Of course, they are mostly concentrated in the countries that have stronger experience and scientific background and funding availabilities. And another interesting issue is that a risk to restore in a system which is not which is subjected to a certain degree of cumulative impacts. Well, of course, restoring in an area which is subjected to annually to trawling makes no sense. But in general terms, we demonstrated that the restoration can be very successful also in habitats from which the chronic impacts, not the acute, not the physical damage, but the chronic impacts are present. And this offers an important opportunity because in general terms, the Society for Ecological Restoration states that, for instance, the forest restoration, you first remove the impacts and then you start the restoration. But of course, asking to remove all impacts from the deep sea before starting the restoration intervention is unpractical, so it's unfeasible. So we wanted to explore whether we can start in any case, and it's possible, of course, if we then protect the intervention from further trawlings. And another issue is, well, think I'm investing that and I'm paying and I'm putting money in this and efforts and technologies. Well, I do not achieve the 100%, I do not achieve the 70%, but is that possible that I have a complete failure, so 0% will survive? The experience accumulated in all available studies is that you have a risk only for very shallow water systems, mangroves, seagrasses, salt marshes, due to eventually rough sea conditions, physical conditions, but it's really negligible for deep sea habitats. Another issue is, well, but we can increase the efficacy and efficiency of restoration in over large scale, or we can also, we haven't a lot of money, we want to start, but we can't cover many square kilometers. Can we do that in just 1 hectare? No. Yes, you can do that, because there is no difference in the success, not significant difference success, if we do that on a small scale or in a large scale. This gives also the opportunity to make multiple small-scale interventions that can then give a cumulative growing impact. And there are no latitudinal constraints. You can do that from Iceland to the Israel in the case of the reserves project or in all other cases. Then another issue is, well, I want to optimize their restoration success, so I want to make sure that I increase as much as possible the restoration success. What should I look at? And according to the meta-analysis we did, the methodologies that are improving year by year with refined protocols. Then also the use of combined restorations of multiple habitats and whatever, the reuse of organisms, the use of cold water corals colonizing reefs or rigs or marine litter, whatever, that is very, very useful, is a good driver. And the maintenance, of course, is also important, as well as the site selection, because, of course, if we restore a damaged area, we are going to put back the same habitat types and on others that might have a lower probability of success. And which are the potential drivers of failure? And the most important one is when you select the wrong location, of course, or you get extreme events, as in the case of the shallow water habitats, mangroves or seagrasses, which have been diverted by storms or other extreme meteorological conditions. And getting back to the problem that is a real issue beside the science that we are doing is then put down on the floor. So realizing what the science demonstrates is feasible and we have appropriate protocols. Is that feasible in terms of return of investments? Well, it depends, of course, habitat by habitat types. For some kelp forests, for instance, the return can be up to almost $100,000 per hectare per year. And still we are calculating, and we have presented a published paper on the ecosystem services benefits and costs of deep sea ecosystem restoration that demonstrate that deep sea ecosystem restoration is convenient also in the case of the cost-benefit analysis for the canyons of the Mediterranean Sea. And this is a case that could be expanded to other areas. So in other words, restoring as a return. But to promote investment in ecosystem restoration, and particularly on deep sea ecosystem restoration, we have some policy enablers. We have one very important one, which is related to the natural restoration law. Now I'm one of the members of the working group for defining the rules for applying the articles of the Natural Restoration Law, and in particular the Article 5. So there are the policy conditions for that. But then we need the money. So we need the economic enabler. So this means that we have a stronger evaluation, the social and the economic benefits. And then the third is the technological enablers, because we need technologies to upscale deep sea ecosystem restoration, to do ecosystem restoration and to upscale ecosystem restoration, and I would say also to reduce the cost for restoration that were expected to be very high, but can become more reasonable in the future. And reducing the cost of restoration of deep sea ecosystems is a crucially important issue that we try to work on this analysis published recently on engineering for the development of the technologies that can enable deep sea ecosystem restoration. Of course, we also develop management strategies, because when we talk about deep sea in particular, but in general for the marine systems, we are defending a public interest and reversing the biodiversity loss and the marine habitat degradation is a clear priority. One of the solutions to make more effective deep sea ecosystem restoration is coupling the active interventions with the passive restoration. So protecting the areas surrounding the areas which have been restored to expand the effects of restoration and to, of course, gather a much larger benefit of the expansion of the aerial expansion of the restoration. And this is one of the best practices that was demonstrated to be very, very effective in other cases. Concluding, we might say that marine ecosystem restoration is at the pioneer stage when compared to terrestrial ecosystem restoration, of course, which dates back to more than 100 years. We have started maybe 30, 35 years ago, the first restoration interventions on tropical corals, and more recently, we adopted the restoration of the mangroves and the seagrass and the macroalgal forest, the kelp forest, as one of the priorities for the United Nations and the Agenda 2030. But I think we are mature for also expanding the targets for deep sea ecosystem restoration, especially those which are damaged by deep water trawling or infrastructures. The evidence we accumulated so far, even though based on a limited number of studies, indicate that there is a very low risk of complete failure. So far, we hadn't a single case of complete failure of deep sea ecosystem restoration among the published studies. But we need to scale up the restoration interventions and to couple restoration with the protection of the surrounding areas, including degraded areas. So expanding the opportunity of a protection, which includes also damaged areas, which were once certainly very productive and rich in biodiversity and have lost the biodiversity due to the physical damage. Future perspectives, very final slide. We have to further improve the protocol, expanding the protocols. There is one important study funded by Biodiversity Plus for the restoration of the polymetallic nodules, but there are some efforts to be done also for hydrothermal vents, cold seeps, other deep sea areas, and habitats. And we need to do more for reducing the cost, and we need to do also more for creating a business able to attract the private investors. I'm convinced that soon deep sea ecosystem restoration will be wider and deeper. But at the same time, having the tools to restore deep sea habitats doesn't mean that we can allow and permit the further damage and destruction of deep sea habitats in the future. Edward Osborne Wilson was stating the next center will, I believe, be the area of the restoration ecology. And I'm convinced this will be the case. And I hope that more and more scientists in the future will find a way to contribute to the scientific advancements we need to get successful deep sea restoration soon. Thank you very much for your attention, and I give you the floor.
Thanks very much, Roberto. That was really great. Maybe you can stop sharing your screen.
Sure.
That would probably make it easier. All right, so I had some questions of my own, but unfortunately, I have questions. Well, fortunately, I have questions in the Q&A, so I'll start with those. First, Dina Epargina, who asks, she says, thank you very much for the talk. And do you have any examples of where you have secured funding, somebody has secured funding for restoration efforts, specifically in the deep sea?
Yeah, so far we have two ways of funding. One is the investment that is being done by the European Union by financially supporting not just the project as the redress for developing protocols and showing the feasibility of the deep sea restoration, but also for life projects, which are projects dedicated to practical intervention. And this is one. The second is related to the public sector for the time being. Public sector will invest, of course, given the priorities that we are, given the priority that we are looking for the natural restoration law. The third is related to the development of the renewable energy sector. Think about the floating offshore wind farms or the simple cables, pipelines, whatever. We know that we should minimize, and we do minimize the impacts, but still some accidental or residual, so defined residual impacts remain. And so the private sectors that invest in that will be asked to invest and to pay for the restoration of the marginal impacts. And this is a way forward also to include in the future more opportunities for developing this sector.
Can I maybe follow on from that? So are you saying that this is something that you're proposing, or it's something that's happening, the last example?
No, that's the last example. The environmental impact assessment is something that is already defined by the European law and the national law, so something that is happening already.
Yeah, but you were saying that we could ask them to pay for any impacts, and then that could be used for
Yes.
restoration. But I'm not sure that that's already happening.
This is happening when you give the permission, the permitting phase, either in the, say, in theory, so when there is the creation of the new infrastructure, and it's planned also for the decommissioning. So there are two phases in which you are, besides accidents and whatever, there are two cases, yes.
Okay. And those are usually a national competence. So, it might be that this is the case in Italy, but I don't know if it's necessarily the case in Spain, I imagine.
It is the case also in Spain. At the beginning, they didn't want to screen it with the environmental impact assessment. Now they do that also in the specific case of the floating offshore wind farms, while the rules for the environmental impact assessments are European rules that are then, applied in every country.
Okay. And then we have a question from Justine Texeria. Do we understand enough on the whole of the deep sea system to justify active restoration interventions? The evidence shows low risk of total failure, but their systems are extremely old and thus their process is probably relatively slow. How do we account for impacts beyond a couple of decades that we've already been studying here?
Well, this is a multiple question, but we can say we do understand enough. We understand enough for some habitat types, and but still little, and we understand much less for other habitats. One of the say paradigmatic or charismatic cases are the deepwater corals. This is the case of the oil companies in Norway or in other areas, which are, of course, very careful in that. And for them, we know that the impact, we know exactly where we have the impact, the extent of the damage, and we have the technologies and techniques and protocols to restore. Of course, Justine is right, that takes very long, but I want to repeat again and again that being able to restore doesn't mean to allow the people and the companies to destroy more. It's just the restoration according to the Society of Ecological Restoration, which is an international society, which defined the definition, the scopes, or whatever, was supporting also the natural restoration law, is restoring the past damage, not to restore the future. That is called technically compensation and not restoration.
All right. Perfect, thanks. And then Alea Balaran says, thank you very much. I was wondering, how can you continue to ensure that the success of the deep sea restoration if efforts are conducted in areas that aren't marine protected areas?
Yeah, exactly. This is an issue, of course, and I hope I try to explain that. When you do a restoration intervention, then you have to protect your intervention. Now, technically, marine protected areas are not designed to protect degraded areas, but just to protect, beautiful areas, hotspot of biodiversity. At the same time, I hope that soon, with the passive restoration, the European Union will include another section of protection, the one dedicated. For instance, we have the fisheries restricted areas to replenish and restock in the fisheries. This is a kind of um, impact restricted area to promote the resilience after restoration intervention, and should get another terms, which is not other effective conservation measure, but maybe will be a new definition for that, but is more similar to other effective conservation measures, maybe more other effective restoration measures of protection.
Yeah. Okay, I'm not seeing any other questions. If people have more questions, please put them in the Q&A. In the meantime, I get to ask my own questions, which is great. My first one was really about the nature restoration law, and from everything I've heard in the marine environment in general, we don't have a really good idea of what we have, so we don't know what we've lost, so we don't know what we need to restore. And I would imagine in the deep sea it's even worse. So how do, or maybe you can't answer that question, but how do you think do we have to deal with this in the next little while, where yeah, how do we deal with the fact that we don't know how much of the deep sea, of a specific habitat in the deep sea, we've lost, so we don't know how much we need to restore, and how will countries have to deal with that?
Yeah, Sheila, you are touching the point. I mean, this is the big elephant in the shop, per se. The issue is that, of course, we know that deep sea habitats are tricky and problematic because they are far from us. They can be seen only if you have a fantastic ROV, working class, expensive, with limited number of hours for exploration. But there are a few projects dedicated by the European Union exactly to that. One, for instance, has been just approved, is the Life Mapper that aims to map the areas degraded, to plan and prioritize the areas to be restored. Of course, we need a contribution by all member countries that have to make a census. Of course, that is easier on terrestrial ecosystems than on marine ecosystems, and is easier on shallow water than on deep sea. But we need to make an effort. If I want, I tell you, I make a spoiler of the approach we want to use. That is that looking at the track of the fishing vessels and their deepwater trawling, we may have a quite good idea, monitored by the surface, on the area, the intensity and frequency. Of course, then one issue is calculating the surface that needs to be restored, which is something amazing and scaring, I would say. Another issue is restoring these habitats, but I think we should start from there. The mapping of sea lines, oil and gas, and the bottom contact fisheries would give a good proxy, maybe not 100%, but maybe 95 and more of the damage of the deep sea habitats.
Mm-hmm. Mm-hmm. And then I have another question about sort of another legal question about it's okay. So we have the EIAs and all of that in the European Union, and we have in most countries there's some sort of legal reason that you should fix what you've made, the mess you've made. But what happens in the areas beyond national jurisdiction? What happens in the Clarion and Clipperton zone? Whose job is that going to be? You're muted. You're muted again.
To the best of my knowledge, we are facing a pretty much similar, case for the area, and the International Seabed Authority should look now together with the Hague Sea Treaty, which has been approved last year, on how to manage for the impacts. So basically, in the future, every activity in the area will be subjected to an environmental impact assessment, which of course include mitigation actions and compensation actions, if any. And that is absolutely clearly the case in the case of deep sea mining. The problem is that the High Seas Treaty took more than 16 years to be approved because the country that wanted to have a concession and the area for trials and exploitation didn't want to match the two. So they wanted to get, to be allowed to do that without doing any restoration. So the problem is that for the areas that have been already given, we are going, because you cannot apply retroactively, the treaty. And for the future, however, we might have a better opportunity to mitigate and even to develop the protection.
Okay, so then we have another question from Alexandra Mayasanj saying, again, thank you. Do restoration projects in the deep sea consider to any extent genetic connectivity between reefs?
This is another important issue to solve because we know that there is an issue on genetic connectivity, which is part of some studies we are doing. Basically, the best solution is that if we use a recruitment in the area where we want to restore, maybe close by or exactly within the damaged areas, we of course attract the larvae and organisms that are part of these cell of ecosystem function, if you want to call it. And so the genetic issue is not a problem. It might be a problem if you move, deep water corals, larvae, whatever, from Ireland to the Med Sea or vice versa. But this is not the case.
Okay, so yeah, I mean, it makes sense that you would try to restore from something close by, I guess. Yeah. And then I had another question on the litter. You mentioned that you could maybe, if you have big pieces of litter that has already things growing on it. I didn't quite understand. Did you mean that you would just leave it there, or you would move it to where you need it to be? Is there some? Maybe you can explain that better for us.
Thank you for this question that allows me to clarify that the idea is that when you do the decommissioning, we have more than 4,000 oil and gas platforms to be decommissioned. 40% of the under 30 oil and gas platforms to be decommissioned in the Adriatic Sea are exhausted, so are not working since many, many decades, not years, decades. So, of course, the oil and gas companies don't want to do that because it's a cost. But they have to, according to the international rules. If we do that, of course we have a solution is the rig to reef. You leave, cut the part and leave the rest being there. Well, this is one solution. But if you plan for the complete decommissioning, one idea could be get the colonies from there and move the colonies in other places. And there are, kind of solutions, and they are very effective and working in many ways.
Okay, so but there isn't really a plan to use big nets or big pieces of trash that they find, because that to me sounds like the logistics of it seems really difficult.
It's difficult. Of course, it's easier to remove because the paradox is that these structures are periodically cleaned. So these animals are removed and scroll out. And why we could use them. So it's this kind of opportunity to create a new alliance also with the oil and gas companies that will survive for a while, I guess, for increasing the opportunities for restoration. That would be a nice idea of partial compensation.
Yeah. And then maybe that will lead me to my final question. And that was about, I mean, from what you've said there, it looks like there could be a cost benefit analysis that would be positive. So you could actually do this and make some money somehow. But that really depends on companies paying for the carbon credits or for some sort of restoration credit. Is there any mechanism to make that happen?
Yes, of course, for the time being, I see that the main mechanism is through the national or supranational World Bank support. I have evidence that the blue bonds, those that being used for the seagrass, mangrove, kelp forest restoration, are becoming what were the green bonds 10 years ago. So there is a growing effort in that sense. Then we also have, the carbon credits, and then we have also the compensation, which technically allows an industry to create, I don't know, a platform on the shallow waters, but then to pay for deep water restoration. So compensation technically is not repair the damage in the place you create the damage, because maybe you remove a surface, you can do that, but you can do that in another place and maybe in another habitat. The return for private companies is more the ability to run this, because they are not scientists that will be doing the job. But of course, if we are recreating something, it's more difficult that you get the money because you sell, oil, gas, or whatever, or nodules. At the same time, measuring with the economies the willingness to pay, which is the willingness of people to pay, to donate, or to have a small fee or taxation for that, indicates that the deep sea are almost unknown. But when you show the pictures, they love it, and they will be very keen of offering a large budget to protect these, strange, bizarre, but fascinating, ecosystem.
Okay. We have one last question, I see, from Mariah Lane. Following on from my question regarding do we really know what we have and what we've lost? Do you think there's a potential for future biodiversity studies, and what would be used as a baseline if the area has only been assessed post-damage? Very good question.
And this is a fantastic question, because Maria gave opportunity to clarify that the standard of ecosystem restoration everywhere is having reference sites. So knowing exactly, having a change of the biodiversity and knowing exactly the targets, because you have to define it in advance, which is the target you want to achieve. So it's not just, well, I did it and I go, because restoration is a process. It's not that fixing a machine that it was not working, now you go. It's creating the conditions for a recovery that might take a few years, may take a decade. So the expectation can be in the midterms, of course, but you have to know a good chances. You have to have the baseline. And this is also an important opportunity. Restoration and deep sea habitat mapping are an enormous opportunity to gather more information on deep sea biodiversity. Yes.
All right. Thank you very much. That was a really great discussion. I learned a lot, which is always helpful. And for everybody, just to remember that we will have a launch of the document on the 11th of April, if I'm not mistaken. And maybe somebody can put the link to register for that in the chat. And then I just have one more job, and that is to say that we have our next webinar will be on Thursday, the 20th of March. And in this webinar, we will have, again, some talk about the deep sea, because Riwan Leroux is actually one of the working group members from the deep sea. One of our young ambassadors, him and Alexandra Hahn, will be giving you an overview of their research that they were doing while being young ambassadors for the Marine Board. So they will be talking about from coastal waters to the deep sea, marine life under environmental change. So I think it's a good follow-on from this talk of Roberto's. Thank you very much, Roberto. It was really interesting, and I'm really looking forward to the launch of the document.
Thanks to all of you. Thank you very much, Sheila.
Thanks.